Welcome to another Directions Mag Geospatial webinar, today sponsored by our friends at ROK Technologies. I'm Barbary Duke, Editor-in-Chief here at Directions Mag, with our webinar producer, Lynette Qualia. Thank you to the geospatial community for being loyal to us for 25 years. Please continue to read feature articles and daily news, listen to podcasts, and of course, watch more webinars at directionsmag.com. Welcome back, Jason Harris and Ryan Daly. They're ready to talk to you about solving your cloud migration challenges. Welcome, gentlemen. We're glad to have you with us today.
Great. Thanks so much, Barbary. Appreciate it. Well, welcome, everybody. Try to cover a lot of stuff in a short amount of time. So, make note of any kind of questions you might have, and definitely get in touch with us after the webinar. Let's get on and I'll tell you a little quick overview about ROK Technologies. All we do at ROK Technologies is architect, migrate, and manage ArcGIS Enterprise systems in cloud environments. We have an incredible group of ArcGIS Enterprise architects, cloud architects, and security experts that all come together as a team to bring this very specialized level of expertise to our clients. I'm not going to go over them all, but you can see we have all the accreditations and the certifications from Esri and all the cloud providers. But our most recent one, and the one that I'm very proud of, is our Kubernetes specialty designation from Esri. We were the first Esri partners to receive this, and as far as I know, as of today, I think we're the only Esri partner that actually has this designation so far. We did recently do a webinar on this topic with Directions Magazine, so if you have a chance, you can go check that one out too. But let's get on with it. Let's start. We're going to discuss, as we mentioned, the most commonly faced challenges during a cloud migration. So, without further ado, here they are. These are the big three. These are obviously not all of the challenges that we see, but for sure, these are the three most common ones. So first, we're going to talk about integrations with existing on-premise infrastructure. Then we'll go on to cover architecture and deployments of the new cloud system. And then lastly, we'll talk a little bit about migrating all of that content over to the new system. So let's start with on-premise integrations. So first off, ask yourself this question: can we move it, right? In an ideal world, when we make this move to the cloud, we want everything to be in that same physical location. So for example, the database and the ArcGIS server should be in that same physical location. That's where we're going to get the best performance. So make sure and ask yourself this question: if you move your GIS enterprise system and geodatabase to the cloud, are there any other data sources like other databases or file-based data, file geodatabases, that cannot be moved to the cloud? A good example would be, let's say you have a map layer that's getting updated nightly based off a table that's from a different department, and that other department is responsible for updating it, and it sits somewhere else. You can't move that to the cloud. Can you do some type of nightly export from on-premise to the cloud nightly? If so, it's a small amount of data. That's a pretty straightforward problem to solve. We can solve that with a real easy nightly scripted job that runs each night. But what if you, let's say, you depend on some real-time data that resides on-premise? Or what if you need to update a large volume of data nightly? Or maybe there's a reason that you have to maintain a connection to an on-premise file server. Then we may want to consider a direct connection from on-premise to the cloud environment. These are commonly called express routes in Azure or a direct connect in AWS. But these types of connections effectively bypass the open internet and connect your on-premise infrastructure to the cloud with a very high speed and low latency connection, which effectively is going to extend your existing on-premise network into the cloud. But even with this type of very fast, low latency connection, we would still sort of advise against some types of common operations. Like we wouldn't want to publish an ArcGIS server map service that's running on the cloud that was sourced to an on-premise database. It's not to say that it's not possible, it is, but we'd rather use that direct connect to transfer that data that's needed and put that into the cloud-based geodatabase. That still, no matter what, is going to give you the absolute best performance. But these direct connects, this is a great solution for perhaps maybe extending an Active Directory into the cloud. And just generally maintaining fast connectivity with other on-premise systems like databases and file servers. The takeaway here is that is just to make sure that you have identified all the items that can and those that cannot be moved to the cloud. Once you do, devise a plan on how you can maintain access to that required data, whether it be through a simple scripted job or that direct connection. I will say that we don't see many instances where we absolutely must maintain that direct connection. We can usually devise a plan to get that required data over in some type of scripted job. But when you do require that on-prem data connectivity, these direct connection services are really, really invaluable. Next, we're going to quickly talk about architecture and deployment patterns. So the next big gotcha when doing a migration usually happens when it's time to actually plan your cloud deployment. And there are lots of different things that can come into play here. So for example, do you do a one-to-one match? Meaning, do you take the specs of your on-premise system and match those, one-to-one in the cloud? Okay, that can be a very good jumping off point, certainly. But make sure you take a really close look at what your on-premise server resources look like before choosing an equivalent cloud-based server instance types. One of the obvious benefits of moving to the cloud, to a cloud system, is the elasticity or that ability to scale your servers up and down based off load. Point being, you don't always have to deploy the biggest and the baddest server into the cloud. In fact, we'll often see organizations greatly over-provision their servers, and that is a huge waste of money. Now, at the other end of the spectrum, we will see some folks do exactly the opposite. They'll utilize server instances that are way undersized for the expected amount of traffic or the number of map services that they have published. Picking that right instance to run your workload needs to be a balance of performance and costs. And it's tough sometimes because there's lots and lots of different types of these virtual machine instance types to choose from. Some of them come with lots of CPUs, some come with lots of RAM. There's some that have really high bandwidth connections. But there are many times you might be able to deploy a burstable class machine that can save you quite a bit on costs. These types of virtual machines, like for example, a T-class machine in AWS or a B-class machine in Azure, can be great choices if you have a fairly predictable type of workload. So when you think about it, and I'm going to guess this is probably true for many of us out there that are managing servers, enterprise servers today, you're going to see the vast majority of your traffic is going to be coming between working hours, say 8 a.m. and 6 p.m. And then for the most part, they're going to sit idle overnight. In this scenario, this is a great example of how you can potentially use a much less expensive burstable class machine. Use up your bursting credits during the day when the servers are getting hit. And then essentially when they're mostly idle overnight, they can build those credits back up for the next day. It's a great money-saving tip there. Another big point to consider when planning your migration is how can you utilize cloud-first technologies in your move to the cloud. There are a lot of examples that I could talk about here, but honestly, I think my favorite one is based around storage. So let's say, here's an example. Let's say you've got terabytes and terabytes and terabytes of rasters that need to be served out with image server in your new cloud environment. Typically, if you were doing this on premise, these rasters would be stored on, expensive local disks or even more expensive SAN-based storage. So when you make that move to the cloud, of course, you're still going to need storage for those rasters, but they can be placed in object-based storage, like Amazon's S3 buckets or an Azure Blob. These rasters can be served and utilized from these much cheaper classes of storage. There's no need to provision those expensive SSDs to store these rasters. You can just put them in object storage. That's basically going to be pennies on the dollar versus expensive SSD. This is a really, really great example and a fantastic use of cloud-based infrastructure. Next, let's talk a little bit about how you deploy your new cloud system. And if you're new to the cloud, or if you aren't familiar with deploying a full Esri stack, then I would guess that many of you out there have probably played with one of the cloud builder templates. They're out there. I'm sure everybody's at least heard of them. Some have played with them. These are those kind of all-in-one configurations where you fill out some information and then it's going to deploy the enterprise for you. And I know that sounds great on paper, but when it comes right down to it, these are not the best options for a production environment. Speaking from some experience, when we get calls from folks, clients out there that need someone to come in and fix an existing Esri cloud deployment, I can tell you with a pretty high degree of certainty that 9 times out of 10, they were deployed with a cloud builder template. What it does is it tries to do everything for you, and it can do that. But what's happening in the meantime is you're losing out in really truly understanding on what's going on when we're relying on these cloud builder templates. So then when problems invariably arise, I think we all know that they will, people are stuck because they don't really have a full understanding of how that system was deployed, as it was all done sort of behind the scenes with a wizard-like interface. So maybe you're stuck and you go, did it deploy a load balancer for me? How is it forwarding my traffic? Did it put all of my servers in a public-facing subnet? These are issues that we run into all too often and more than you would think. But here's the good news. If you deployed your enterprise system into a well-architected framework, we'd already know the answer to these questions. So making sure that you have a solid framework in place, proper subnets, proper security policies, routing, it's absolutely critical to your cloud deployment being a success. This is a really big this is a really big topic. So let me take a couple more minutes. I'm going to review a sample architecture and some common security issues to look out for. First, I think we can probably all tell that I did not make this slide because it has some very nice fancy graphics. Big shout to Ryan Daly for helping out with this slide. Much appreciated. So what we're looking at here are some 3 very common security and infrastructure mistakes that you should be on the lookout and kind of how to avoid them. Mistake number 1 is deploying all of your enterprise components onto one single machine. Sure, this might be okay for a very simple deployment, a simple development environment, but folks, don't do this in production, please. Since what happens is we've packed all of the enterprise components like server and portal and data store onto one machine, they will effectively be fighting each other for the limited compute resources on this one single machine. This is ultimately going to lead to poor performance, resource exhaustion, and eventually downtime. The solution here is pretty easy. Just distribute your enterprise components onto their own machines, their own virtual servers. Mistake number 2, overexposure. When you deploy that new system, make sure, like I said before, that there's a well-architected framework in place. In this case, I'm specifically talking about proper subnets and security rules. So for example, some subnets are public-facing and they get a public IP address. Some are private, which you cannot reach directly from the internet. Don't make the mistake and deploy all of your machines into a public-facing subnet, as this is a huge security risk that, yeah, we really do see all too often. You want one single public entry point into your system on port 443, which we all probably know is HTTPS, and that goes to the web server or web adapter. And then from there, you can set firewall rules to allow that web server to communicate securely with the other servers in private subnets. Never ever have your ArcGIS server or your database or other application servers directly publicly accessible. Separate your servers into a multi-tiered and logically grouped subnets. Mistake number 3, mixing your production and development environments. Lots of folks need development environments to test out new apps or to validate a new release of ArcGIS Enterprise. This is a very common scenario. I think most of us probably have some type of development environment that we use. The problem starts to happen is when that development environment can talk to the production environment and vice versa. It's pretty common to see someone unknowingly, make a change to what they thought was the development server, but it accidentally happened in production. And that can potentially be catastrophic and create serious, significant downtime. The solution here, once again, pretty easy. We'll go back to that well-architected framework. Make sure that we logically separate production from development. With proper subnets and rules in place, we can isolate these two environments from each other, which will help eliminate costly mistakes. And the last big topic is content migration. So last on the list, and probably in my mind, this is the biggest challenge of the bunch. That's moving your on-premise content to the cloud. Now, when I'm talking about that, I don't mean moving our files like our database backups or our map documents or file geodatabases. What I'm talking about here is moving your existing ArcGIS Enterprise content, things like your map services, your portal content, or data store contents. If you've ever tried to migrate this content to a new server stack, then this is not an easy or straightforward task. ArcGIS Enterprise can be, trying to have a good word here, can be somewhat particular about its configuration, right? One tool that we can use is the Esri provided WebGIS DR tool. This tool was essentially designed to create a backup or a copy of your entire enterprise system for the purposes of disaster recovery. You could then use this tool to back up and then restore this WebGIS DR if a disaster were to strike your infrastructure. However, we can also use this tool to essentially package up our on-premise system and move it to the cloud. When you run a WebGIS DR, the output that it creates is really just a big zip file with all of the content and some properties files, all the content from your portal and your server and your data store along with some property files. You could then transfer that file to the new system and restore it. There are some gotchas when using this method. Your new system, in a general sense, needs to match your previous on-prem system. So, for example, the new cloud system already needs to have enterprise set up and configured first. The new cloud system should have the same data and configuration directories as your previous on-premise system had. The web adapter, URL on the new system has to match what was previously configured on-premise. Databases that were used in ArcGIS data sources should already be in place. That name of that database server needs to be the same, or you can alias it. Those are really just a couple of the caveats. I could go real deep on this one. If you're interested in really learning more about this method, you can drop me a note and I'll give you the full rundown on that. But there's a lot of caveats, but if used correctly, it can work. Another method that we can use is the lift and shift, right? There are many tools available to accomplish this, but in short, these tools will take a bit-for-bit copy of your existing machines on premise, and it will recreate or clone them into the cloud environment. It sounds simple, But because of the nature of an ArcGIS system, an enterprise system, there are some things that you would probably need to be careful with, mainly centered around an Active Directory if it's going to be a Windows-based system. Also, it brings over everything, warts and all, so stuff we might not want in our new system. To be honest, we don't utilize this method all that much because because in the end, after long discussions about the different pros and cons with our clients, we usually settle on starting with a brand new, properly architected and empty enterprise system. This way we can get a fresh start and not have to worry about migrating all the junk that may have been accumulating on that on-premise system over the years. So when we start fresh, we can selectively republish the important map services, the ones we need. We can migrate portal content over as needed. We can use Python scripts to do that. We can use the ArcGIS Online Assistant or other third-party tools, maybe like GeoJob's backup.org. So these are the key takeaways. Do you have any on-premise dependencies that would impact your cloud deployment? If so, devise a plan to mitigate those issues. Next, choose your deployment method wisely and make sure that you have a secure and well-architected framework in place that can take advantage of cloud technologies. Lastly, you'll need to consider how to best migrate your enterprise content into the new environment, or perhaps consider starting with a fresh, brand new system that you can selectively migrate your content into. I know that was quick. I know we covered a lot. It's really just my hope that this gave you a good jumping off point. Things that you should start thinking about if you're looking to make that move into the cloud. That's it. Really appreciate everybody joining. Check out the QR codes and the email on the slide there. Definitely get in touch. Sadly, I enjoy talking about this stuff, so always feel free to get in touch if you'd like to talk some nerd.
Hey, thanks, Jason. We really appreciate you being here today. Also appreciate Ryan and Kate for their input as well. We hope everyone makes it a great day. Tell a friend about ROK Technologies and Directions Magazine. Thanks, everybody. Welcome to another Directions Mag podcast, co-hosted with our friends at ERISA. Welcome to another Directions Mag podcast, co-hosted with our friends at ERISA.